The energy industry is the totality of all of the industries involved in the production and sale of energy, including fuel extraction, manufacturing, refining and distribution. Modern society consumes large amounts of fuel, and the energy industry is a crucial part of the infrastructure and maintenance of society in almost all countries. In particular, the energy industry comprises the petroleum industry, including oil companies, petroleum refiners, fuel transport and end-user sales at gas stations. The gas industry, including natural gas extraction, and coal gas manufacture, as well as distribution and sales. The electrical power industry, including electricity generation, electric power distribution and sales. The coal industry. The nuclear power industry. The renewable energy industry, comprising alternative energy and sustainable energy companies, including those involved in hydroelectric power, wind power, and solar power generation, and the manufacture, distribution and sale of alternative fuels. Traditional energy industry based on the collection and distribution of firewood, the use of which for cooking and heating is particularly common in poorer countries. History. The use of energy has been a key in the development of the human society by helping it to control and adapt to the environment. Managing the use of energy is inevitable in any functional society. In the industrialized world, the development of energy resources has become essential for agriculture, transportation, waste collection, information technology, communications that have become prerequisites of a developed society. The increasing use of energy since the Industrial Revolution has also brought with it a number of serious problems, some of which, such as global warming, present potentially grave risks to the world. In society and in the context of humanities, the word energy is used as a synonym of energy resources, and most often refers to substances like fuels, petroleum products and electricity in general. These are sources of usable energy, in that they can be easily transformed to other kinds of energy sources that can serve a particular useful purpose. This difference vis-a-vis energy in natural sciences can lead to some confusion, because energy resources are not conserved in nature in the same way as energy is conserved in the context of physics. The actual energy content is always conserved, but when it is converted into heat, for example, it usually becomes less useful to society, and thus appears to have been used up. Ever since humanity discovered various energy resources available in nature, it has been inventing devices, known as machines, that make life more comfortable by using energy resources. Thus, although the primitive man knew the utility of fire to cook food, the invention of devices like gas burners and microwave ovens has increased the usage of energy for this purpose alone manifold. The trend is the same in any other field of social activity, be it construction of social infrastructure, manufacturing of fabrics for covering, porting, printing, decorating, for example textiles, air conditioning, communication of information, or for moving people and goods. Economics. Production and consumption of energy resources is very important to the global economy. All economic activity requires energy resources, whether to manufacture goods, provide transportation, run computers and other machines. Widespread demand for energy may encourage competing energy utilities and the formation of retail energy markets. Note the presence of the energy marketing and customer service subsector. The energy sector accounts for 4.6% of outstanding leveraged loans, compared with 3.1% a decade ago, while energy bonds make up 15.7% of the $1.3 trillion junk bond market, up from 4.3% over the same period. Management. Since the cost of energy has become a significant factor in the performance of economy of societies, management of energy resources has become very crucial. Energy management involves utilizing the available energy resources more effectively, that is, with minimum incremental costs. Many times it is possible to save expenditure on energy without incorporating fresh technology by simple management techniques. Most often, energy management is the practice of using energy more efficiently by eliminating energy wastage or to balance justifiable energy demand with appropriate energy supply. The process couples energy awareness with energy conservation. Classifications. There is no distinct classification for an energy industry, because the classification system is based on activities, products, and expenditures according to purpose. Countries in North America use the North American Industry Classification System. The NAICS sectors number 21 and number 22 might roughly define the energy industry in North America. This classification is used by the U.S. Securities and Exchange Commission. Financial market. The Global Industry Classification Standard used by Morgan Stanley define the energy industry as comprising companies primarily working with oil, gas, coal and consumable fuels, excluding companies working with certain industrial gases. Add also to expand this section, Dow Jones Industrial Average Environmental Impact. Government encouragement in the form of subsidies and tax incentives for energy conservation efforts has increasingly fostered the view of conservation as a major function of the energy industry. Saving an amount of energy provides economic benefits almost identical to generating that same amount of energy. This is compounded by the fact that the economics of delivering energy tend to be priced for capacity as opposed to average usage. One of the purposes of a smart grid infrastructure is to smooth out demand so that capacity and demand curves align more closely. Some parts of the energy industry generate considerable pollution, including toxic and greenhouse gases from fuel combustion, nuclear waste from the generation of nuclear power, and oil spillages as a result of petroleum extraction. Government regulations to internalize these externalities form an increasing part of doing business, and the trading of carbon credits and pollution credits on the free market may also result in energy saving and pollution control measures becoming even more important to energy providers. Consumption of energy resources requires resources and has an effect on the environment. Many electric power plants burn coal, oil or natural gas in order to generate electricity for energy needs. While burning these fossil fuels produces a readily available and instantaneous supply of electricity, it also generates air pollutants including carbon dioxide, sulfur dioxide and trioxide and nitrogen oxides. Carbon dioxide is an important greenhouse gas which is thought to be responsible for some fraction of the rapid increase in global warming seen, especially in the temperature records in the 20th century, as compared with tens of thousands of years' worth of temperature records which can be read from ice cores taken in Arctic regions. Burning fossil fuels for electricity generation also releases trace metals such as beryllium, cadmium, chromium, copper, manganese, mercury, nickel, and silver into the environment, which also act as pollutants. The large-scale use of renewable energy technologies would greatly mitigate or eliminate a wide range of environmental and human health impacts of energy use. Renewable energy technologies include biofuels, solar heating and cooling, hydroelectric power, solar power, and wind power. Energy conservation and the efficient use of energy would also help. In addition, it is argued that there is also the potential to develop a more efficient energy sector. This can be done by fuel switching in the power sector from coal to natural gas, power plant optimization and other measures to improve the efficiency of existing CCGT power plants. Combined heat and power, from micro-scale residential to large-scale industrial. Waste heat recovery. Best available technology offers supply-side efficiency levels far higher than global averages. The relative benefits of gas compared to coal are influenced by the development of increasingly efficient energy production methods. According to an impact assessment carried out for the European Commission, the levels of energy efficiency of coal-fired plants built have now increased to 46 to 49% efficiency rates, as compared to coal plants built before the 1990s. However, at the same time gases can reach 58 to 59% efficiency levels with the best available technology. Meanwhile, combined heat and power can offer efficiency rates of 80 to 90%. Politics. At the national level, governments seek to influence the sharing of energy resources among various sections of the society through pricing mechanisms, or even who owns resources within their borders. They may also seek to influence the use of energy by individuals and business in an attempt to tackle environmental issues. The most recent international political controversy regarding energy resources is in the context of the Iraq Wars. Some political analysts maintain that the hidden reason for both 1991 and 2003 wars can be traced to strategic control of international energy resources. Others counter this analysis with the numbers related to its economics. According to the latter group of analysts, U.S. has spent about $336 billion in Iraq as compared with a background current value of $25 billion per year budget for the entire U.S. oil import dependence policy. Energy policy is the manner in which a given entity has decided to address issues of energy development, including energy production, distribution and consumption. The attributes of energy policy may include legislation, international treaties, incentives to investment, guidelines for energy conservation, taxation and other public policy techniques. Security. Energy security is the intersection of national security and the availability of natural resources for energy consumption. Access to cheap energy has become essential to the functioning of modern economies. However, the uneven distribution of energy supplies among countries has led to significant vulnerabilities. Threats to energy security include the political instability of several energy-producing countries, the manipulation of energy supplies, the competition over energy sources, attacks on supply infrastructure, as well as accidents, natural disasters, the funding to foreign dictators, rising terrorism, and dominant countries' reliance to the foreign oil supply. The limited supplies, uneven distribution, and rising costs of fossil fuels, such as oil and gas, create a need to change to more sustainable energy sources in the foreseeable future. With as much dependence that the U.S. currently has for oil and with the peaking limits of oil production, economies and societies will begin to feel the decline in the resource that we have become dependent upon. Energy security has become one of the leading issues in the world today as oil and other resources have become as vital to the world's people. With new advancements in renewable resources, less pressure has been put on companies that produce the world's oil. These resources are geothermal, solar power, wind power and hydroelectric. Although these are not all the current and possible future options for the world to turn to as the oil depletes, the most important issue is protecting these vital resources from future threats. These new resources will become more useful as the price of exporting and importing oil will increase due to increase of demand. Development. Producing energy to sustain human needs is an essential social activity, and a great deal of effort goes into the activity. While most of such effort is limited towards increasing the production of electricity and oil, newer ways of producing usable energy resources from the available energy resources are being explored. One such effort is to explore means of producing hydrogen fuel from water. Though hydrogen use is environmentally friendly, its production requires energy and existing technologies to make it are not very efficient. Research is underway to explore enzymatic decomposition of biomass. Other forms of conventional energy resources are also being used in new ways. Coal gasification and liquefaction are recent technologies that are becoming attractive after the realization that oil reserves, at present consumption rates, may be rather short-lived. See alternative fuels. Transportation. All societies require materials and food to be transported over distances, generally against some force of friction. Since application of force over distance requires the presence of a source of usable energy, such sources are of great worth in society. While energy resources are an essential ingredient for all modes of transportation in society, the transportation of energy resources is becoming equally important. Energy resources are frequently located far from the place where they are consumed. Therefore, the transportation is always in question. Some energy resources like liquid or gaseous fuels are transported using tankers or pipelines, while electricity transportation invariably requires a network of grid cables. The transportation of energy, whether by tanker, pipeline, or transmission line, poses challenges for scientists and engineers, policymakers, and economists to make it more risk-free and efficient. Crisis. Economic and political instability can lead to an energy crisis. Notable oil crises are the 1973 oil crisis and the 1979 oil crisis. The advent of peak oil, the point in time when the maximum rate of global petroleum extraction is reached, will likely precipitate another energy crisis.